Okay. Good morning once again. Let me start the lecture. Um, so we have earthquake resistant design. Am I audible?
Yes, sir.
Yes, sir.
So the prerequisite for this course is structural dynamics. So which can be seen in this the syllabus. And there's 2 lecture hours, and there's no tutorial and practical also. I mean, laboratory components are not there in it. And but apart from that, we have J component. So the total credit for this course is free, so that you are aware of it. The main course objectives of this course is to study the basic concepts of engineering seismology and ground motion characteristics, because we are dealing with earthquake resistant design, not only not in general of the vibration studies, but particularly in specific, we are going to deal with earthquake resistant design. So we first must know what is earthquake, and from where it is generated, and after the earthquake arrives, uh, what are the outcome, uh, in what form it will be recorded. Okay, so that and all will be coming under ground motion characteristics. But in engineering seismology, will be studying only about the earthquake engineering. Okay, so about tectonic plates, how earthquake is generated. Okay, the earthquake occurred, and based on that, what are their magnitude, and in what form it is being measured, either in terms of magnitude or intensity. Okay, and what in what form we are referring in our country code, based on which measurement the earthquake is being measured in our country code. Okay, so that and all will be coming under engineering seismology and ground motion characteristics. Then after that, and the second objective is to understand the strength and capacity design of um, principles of the design, principles of earthquake resistant design. So the principle, in short, how our the structure should behave during earthquake. Suppose the earthquake may occur uh, with different acceleration, with different magnitude. Suppose if it is of the low magnitude and moderate earthquake, or otherwise if it is a uh, severe earthquake. Okay, so how your structure, the building structures should behave. So that will be coming under the principles. So like your the building structure may have the main structural components and non-structural components. The structural components are nothing but the main frame, like beams, slabs, columns, then the foundations. These and all will be the structural components, and the non-structural components, that and all the partition walls, the infills, these and all will be coming into non-structural components. Okay, so if anything happens to your the non-structural components, then it won't affect your the overall global behavior of your the building structure. So your structure will be safe. If your suppose any the partition walls or any infill walls get affected, it won't affect your the overall structural behavior. So but in case of, suppose you your any of the beam gets affected, any of the beam or any of the column uh, is getting failed during this earthquake, then it will affect your the structural uh, behavior. Suppose, for example, any one column is failed under the ground floor, in the ground floor, it may lead to subsequent collapse of the structure. Okay. So, but in case of any partition wall failed in the same ground floor, then nothing will happen to your building. Only that partition wall has to be repaired in later. So how the structure should behave under different magnitude earthquake. Okay. So that will be coming under this capacity design and the strength principles of the earthquake resistant design. And to study the behavior of various types of buildings under static and dynamic forces like RC building, without infill, with infill, then steel building, and the structural, the buildings without shear walls, with shear walls. These are all some of the types of building, the types of structures also there, like that the various types of the structures, and even bridges also you can consider. So we'll be studying only the design of RC structure and the steel structures in this course uh, under the static and dynamic forces. So earthquake is the dynamic. Uh, Earthquake will occur in dynamic nature only, but for ease in analysis, we convert this dynamic force into a static force. That method we have is called equivalent static method of the analysis. Okay, so which is given in IS 1893 Part 1, 2016. The latest code is a 2016 code. That only we should follow. So the dynamic nature of the earthquake will be converted for the ease of the analysis to the static force. That is equivalent static force. So under different uh, the static and dynamic forces, how these types of the buildings will behave. That and all will be studying in this course. That is our third objective. And the fourth one, to study the elastic and inelastic deformations and significance of ductility in beam column joint. So we know very well in any type of the member, any type of the building, the joint is a uh, primary thing, right? So if anything happens to your joint, then automatically that the corresponding members will get failed. So how your beam column joint in a building, the joint will be there in the it will exist in the beam and columns. Okay, so that beam column joint. So how it should behave, how it should behave during this earthquake. Earthquake, it is of the cyclic in nature, dynamic in nature. Okay, so during that time, how it should behave, whether it should behave brittle manner or ductile in manner. So we know that brittle manner, if it behaves, there will be a sudden failure of the joint will happen. So, but it should be avoided. That very well. But in ductile manner, if the joint behaves, then we will have sufficient time to identify where the failure occurs. Okay, when then we can uh, stop such failure by repairing it in future. Okay. So we should always design any building or any structural component for ductile nature only. So the fourth objective is elastic and inelastic deformations and significance of ductility in beam column joint. Okay. And to study the seismic behavior of masonry and concrete shear wall systems. So masonry shear wall and concrete shear wall system also will be studying in the same subject, same course, and to study the significance of energy dissipating devices in seismic resistant design. Energy dissipating devices, your the energy that will be generated during this the earthquake event, that should be dissipated for us within a certain period of the time, or otherwise the continuous build-up of the strain or the stresses will occur. So continuous build-up of the strain or stresses will occur in a member if the structure is subjected to vibration for a longer period of the duration. You just imagine if you apply any force, if it comes to its original position within a short period of the time, then that means it is not subjected to any kind of the force for the longer duration. Or otherwise, after application of the force also, if it starts vibrating, if it continues vibrating, then the continuous buildup of the strain or the stresses will be there in that particular member. Okay. So that should be stopped. That continuous buildup of that the stresses should be stopped by the dissipation of this energy. So for energy dissipating in a member or in a building, we have certain devices. One is dampers we can provide, and another one isolators we can provide. Okay. So isolators, and another one bracings also we can provide. So bracings, it will of course it will increase its structural stiffness so that your acceleration will increase, but it will reduce its structural displacement. Okay. So but in case of the dampers and uh, base isolation devices. So dampers can be provided anywhere inside the building, okay. But base isolation should be provided below your at the base of your structure. Okay, so at the between your foundation and the structural level, your isolation devices will be provided. So we will study the significance of this energy dissipating devices in seismic resistant design. These are all the main objectives of this course. So in first module, as already mentioned, we have seismology and earthquake. So it will be we'll be dealing about the internal structure of the earth that you would have already studied in your geology, engineering geology, or in your lower graduate degrees also. In your the schools also you studied internal structure of the earth. Earth is of it has three parts, right? The upper one is crust, and the middle one is mantle, and the inner one is the core. Okay. Again, inner core, outer core, inner mantle, outer mantle. Okay. So in outside the crust only we people live. Okay. So that internal structure of the earth, and continental drift and plate tectonics, faults, and elastic rebound theory, seismic waves and characteristics, earthquake size. Okay, so this earthquake size only we'll be knowing that the magnitude of the earthquake. You would have seen in many of the news, like after occurrence of the earthquake. The earthquake hit with a magnitude of 7 or 5.8, like that. Okay, so that magnitude is based on there are four types of the magnitude: body wave magnitude, and surface wave magnitude, then uh, moment magnitude, and of course the last one is the Richter magnitude. Okay, so the earthquake hit with the Richter scale of 7.7, like that you would have heard in the news. Okay. So that is the magnitude. The earthquake size will be measured in terms of magnitude and the intensity. Okay. So that will be coming under this earthquake size. And strong ground motion. Strong ground motion. Suppose if the earthquake is of the high magnitude, then the ground motion will be very strong. So it will generate very high uh, ground accelerations. Okay. So that and all will be coming in a strong ground motion. Seismic zoning map of India. So in our country we have 4 zones. Earlier we have 5 zones, starting from zone 1 to zone 5. But currently we have it is again categorized into 4 only. Okay. So the zone 1 is removed, and the zone 2, starting from zone 2, 3, 4, and zone 5. So out of all these 4, zone 5 is the severe zone. Okay. So it has the magnitude, not magnitude, it has the zone factor of 0.36. Okay. So how it is being classified, how these values are given, we'll see in the first module. And seismic hazard assessment. Suppose if you are going to construct the nuclear power plant or any of the important buildings in a particular place. So, and your seismic zone factor of that particular place is something zone 4 or zone 5. So you cannot simply assume that value, zone 5 or zone 4. Instead of that, since your building is of highly important, you should assess, is there any earthquake, the faults, or in the near around the in and around the that the proposed site. Okay, so from that fault, when and where the earthquake occurred in the previous the history, that all you should identify, and it's the location, the distance, and the magnitude of the earthquake. Everything you should first collect from the seismic seismology of the country. Then based on that, you should calculate, estimate the expected ground motion acceleration in a particular period of the time. Okay. So that is seismic hazard assessment. So there are two methods. One is deterministic seismic hazard assessment, DSHA, deterministic seismic hazard assessment, and another one, probabilistic seismic hazard assessment, PSHA. Okay. So so you'll see this the first one uh, in the afternoon, the lecturer. Now let us discuss about our J component project. Are you listening?
Yes, sir.
Yes, sir.
Okay. I already forwarded that the topic I have not decided it because I still need to get the details from the students, because I initially thought we had 61 students. Okay, of course, but right now the participants are, yes, of course, previously 63, 64 came. I don't know how 64 students came. Um, so I was expecting the details from the students, but still 20 more students have to give the batch details. So based on that only, how many number of the batches are going to come. After that only I need to collect the topics. Okay, so once the batch details are the finalized, then I will give you the topics. Probably today afternoon lecture I'll send you the list. So from that, just a second. Just a minute.
Sir, some people are waiting.
Pardon?
Some students are waiting.
Some students are waiting. Okay. Yeah. Uh, yeah. So afternoon I'll share you the topic list. Now we have to have 3 reviews, right? So in that the first review, this Sunday we will discuss about the topic. So you have to first understand what topic you have got, and you have to search online uh, how to start the work in that given topic. Then we will discuss about it on coming Sunday. Okay. Then your first review will be the next Sunday, 31st May. So it carries 20 marks. So you have to complete your literature survey and at least 25% of the work. See, this is not individual work. It's a group work. So it's your responsibility to share the work and complete it on time. Okay. So you should not say we had only 1 week of the time. So within that, how can I complete the work like that? You should not say any excuses. So that is why we have divided into batches. So the next Sunday you should complete your literature survey of the given topic, and 25% of the work also. It carries 20 marks. So 10 marks for literature survey and 10 marks for the work done, 25% of the work done. And after 2 weeks, June 14th, your 75% of the project work must have completed, and it carries 30% of the 30 marks. And 50% of the work, if you completed, then you will get only 15 marks, and 75% remaining 50. So like that, 30 marks will be awarded to you. And after 14 days, 28 June, all of your work must be should be completed, and you should write a report for a particular journal. We will identify a suitable journal based on your work, and the quality and quantity of the work will identify a journal, and you have to write a report, manuscript. Then you should communicate to the journal. So it carries 50 marks. So 100% of the work, if you completed within this time, you will get 20 marks. And for preparation of the article, you will get 15 marks. And if you have communicated to the journal within that time, then again 15 marks. See, again I'm saying this is a group work. So your responsibility to divide the entire work. Okay. So suppose, yes, tell me.
Hello, sir.
Pushkar.
So, like we,
May I know who is this?
Sir Jayesh.
Jayesh. Yes, Jayesh.
So, like we can communicate to any journals, or is there any specific?
That's why I'm saying, suppose if your work comes very good, based on the quality and quantity, I will suggest.
Okay, sir.
Okay, so I'll suggest the journal. No? Any other doubt? Any other doubt? Anybody has?
Sir.
No.
No, sir.
Okay, fine. So today afternoon I'll give you the topics, the list of topics. But before that, try to give you the topic, the batch details, and the topics can be chosen based on the batch number. Okay, so because they are given their the wish list at the beginning, 2 days, 3 days back itself. Okay, 2 days back, I guess. Okay, so based on the batch number, they can choose their topics. So better give your the batch detail as early as possible. Right now, 13 batches have been formed. Okay, thank you all. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Sir, what is
Thank
afternoon
you, sir.
time?
Pardon?
Afternoon time?
Afternoon 2 o'clock, no?
Okay, sir.
Yes, sir.
Okay.
2 o'clock.
Thank you.
Same link, sir.
Pardon?
Same link,
Same link, sir.
Same? No, I don't understand.
Sir.
Link.
Sir, is it the same meeting ID that we have to use?
Same meeting ID can we use?
Yeah.
How?
Yes, sir.
Okay. How can we use the same
Sir,
meeting ID?
just
You have
Okay, we will discuss later then. Huh?
you have to configure
Okay,
meeting
sir.
as a
Thank
recurring
you.
meeting.
Thank you, sir.